How safe is unsafe? The battery pack shown here is an off-the-shelf military battery containing 24 cobalt oxide-based lithium-ion cells. In this comparative example, we tested the oxide-based chemistry side by side with our Safeon technology. We shot each pack with one 5.56 millimeter bullet to demonstrate what can happen in abuse conditions. The immediate reaction in the cobalt oxide cell is an extreme temperature thermal event at over 700 degrees Celsius. Thermal runaway is manifested by the cobalt oxide cell breaking down and releasing its oxygen, thus sustaining the event. For the Safeon cell, there is no noticeable thermal reaction. As the test continues, the event in the cobalt oxide battery pack appears to slow down and become manageable. But what cannot be seen is the thermal momentum created in the adjacent battery cells from the initial reaction. Despite claims to the contrary, there is no internal or external safety device that can prevent the next series of events. One after another, the remaining 23 oxide cells in the battery pack break down and demonstrate thermal runaway. This creates extreme temperatures, again over 700 degrees Celsius, sustained for over 4 minutes. Each successive cell breaks down, combusts, and aided by the release of oxygen, continues the propagation. Of course, sustained high temperatures in the battery pack also can cause the fire to spread to the surrounding environment, making a bad situation worse. Again, there is no noticeable reaction to the Safeon battery pack other than the direct bullet damage. The cobalt oxide-based cells used in the pack shown in the main window employ the same chemistry that is generally used by notebook computers, cell phones, and other consumer appliances. We realize that these products typically will not be exposed to bullets. However, our tests are designed to simulate abuse conditions that avoid the standard safety devices. Leaving an oxide-based battery exposed to high temperature, crushing the cell with a round bar, or penetrating the cell with a nail or bullet are all proxies for real-life situations. The pack could be overcharged, causing the molecular structure to break down. It could be dropped or impacted in such a way to dent a battery cell. Or there could be a manufacturing defect that causes an internal short similar to the short created by a nail penetration or round bar crush. Safeon technology was designed to be safer. Valence Technology spent years developing an intrinsically safe cathode material that does not readily liberate oxygen, even under extreme abuse conditions. Here is a chart showing the measure of heat flow, or joules per gram. Notice that Safeon material clearly is much more thermally stable than the competing oxides. The oxygen bonds in our cathode material are up to 2 times stronger than the oxygen bonds in the traditional cobalt oxide-based lithium-ion batteries.